Hello students, in this video we'll discuss the first definition we have of the rank of a matrix. Let's be given an m rows by n column matrix A, which is A11, A1n, AM1, AMn, like so. We say that A has rank equal to K, written rank of A is equal to K, if any echelon form of A has exactly K lead coefficients. In other words, the rank is just a count of the number of lead coefficients in a matrix A. So we take A, we put it into an echelon form, a row echelon form, we count the number of lead coefficients in that matrix, and that number is independent of the echelon form that the matrix is in. In particular, it could be in a reduced row echelon form, and that number is going to be the rank of the matrix. Okay? Excellent. Okay? So what is a characterization of this, right? So a characterization of this, so we have a following proposition. So if the rank is K, so a proposition, if A is an m by n matrix, then I, the rank of A, is less than or equal to m. Well, that's obvious because there's exactly m columns in here, so there's exactly m possible locations for lead 1. So there's m at most m lead 1s. Okay. Number 2, if the rank of A is less than or equal to n, right? Because if I put the matrix into reduced row echelon form, then the number of lead 1s is unique to the column. So this follows from the fact that the number of leads are unique to the number of rows, and there's at most n lead 1s. Okay, excellent. Because that's from the reduced row echelon form, right? So if I take a lead 1, I can put all zeros above it, right? And so that says it's unique to the columns as well. So n's the columns and m's the rows. So this over here is a column estimate. So this is a column estimate. And excuse me, this is a row estimate, not a column estimate. So this is going to be a row estimate. That's a row estimate. And this over here is a column estimate. Great. All right. The next thing we have some results about the number of solutions of these things. So 2, 3. Okay. So systems, the augmented system, is consistent if K and K is less than n, then this implies that there are n minus K free parameters. Okay? That's because if there's fewer of the lead 1s than there are in the columns, that means there's going to be some free variables in there. There's exactly going to be n minus K of those free things. Great? And if K is equal to n, then that says there is a unique solution. There is a unique solution. There are no free parameters. That's, of course, because there's no parameters to estimate because I've basically taken up all the columns by the rank of the matrix. Okay, so that's the way we think about rank of the matrix, right? So let's see an example of this. Example. Find the rank of the matrix 1, 1, 1, 1, and then let's do a 2, 3, 3, 3, and then a 3, 4, 2, 2. Okay, so I need to put this into an echelon form. Okay, so I'm going to do the first thing I'm going to do is I'm going to do 2 steps simultaneously. I'm going to do -2 row 1 plus row 2. That will get rid of that 2 over there. Then I'm going to do negative 3 row 1 plus row 3. And what we get if we do this procedure, we'll have a 1, 1, 1, 1 over there. Then we'll zero out this thing over here. And then this is going to turn into a what? That's going to turn into a 1. That's going to turn into a 1. That's going to turn into a 1. And then over here, if I do negative 3 row 1 plus row 3, that's going to be a 0 over here. Then it's going to be a what? It's going to be a 1 over here. And then a what? Then it's going to be a negative 1 over here and a negative 1 over here. Okay, so that's what we're going to get when we reduce this thing over here. Excellent. And then what we do now, what we'll do is we have to zero out that 1 beneath the first one. So I'm going to do a negative row 2 plus row, what? Plus row 3. If we do that, we'll have a 1, 1, 1, 1, a 0, 1, 1, 1, and then a 0, 0, negative 1, negative 1. Okay. Let's see. The last rows are actually incorrect, so let's be a little more careful about that. So let's see what those last entries be. So I do a negative row 2 plus row 3. That's going to be a negative 2, and then a negative 2 over here. And then finally, I'll just multiply the last row over here by a negative 1/2, right? So negative 1/2 of row 3 is going to be what? Is going to be a 1, 1, 1, 1, a 0, 1, 1, 1, and then a 0, 0, 1, 1, like that over here, right? And so we see how many lead coefficients do we have over here. So I know that the rank has to be less than or equal to what? The number of rows, m, and so there are 3 rows here. And how many lead ones do we have? I have 1, 2, 3 lead ones. And so the rank of this matrix, if we call this matrix over here B, then the rank of B is equal to 3. So this is a rank 3 matrix B. Thank you very much.